Okay, so in this video we're going to talk about displacement reactions, alright? These can also be said or be called substitution reactions. So, when we've got a displacement reaction, it is when one metal or ion displaces another metal or ion from its salt. When we say displaces, this means it's taking the place of, right? So basically what we're saying when we're talking about a displacement reaction is that one metal is taking the place of another metal in a salt or in a solution. Okay, so basically it's just been switched about, it's taking the place of another reaction. So for an example of this, imagine we have put iron nails into a copper sulfate solution. Okay, remember from National 5, our copper sulfate is a bright blue solution. Okay, so copper sulfate solution is bright blue. So when we were to put the nails in, the nails will start to turn a kind of copper colour. This is a kind of, as you would know from like copper in wires or a copper penny, it's a kind of bronzy, browny, orangey colour. Okay, so the copper will start to form on the nails, this copper colour, and the blue solution will start to turn green. Okay, so basically what's happening here is, if I was to keep this up, the iron from the iron metal, the nail that we added in, okay, is displacing the copper in the solution. So it's displacing the copper ions in the solution, it's taking their place. Okay, so they're going to switch about. So, with the iron taking the place of the copper in the solution, it's going to form iron sulfate. Okay, so it's just switched about, it's taking, the iron nail is taking the place of the copper in the solution and it's forming iron sulfate. Okay, if you remember I said the nails, I've got it here, will start to turn a copper colour. This is because the copper metal is forming. Okay, so when the copper metal is forming, the iron is taking the place of the copper in the solution. This is what causes what we know as a redox reaction. So from National 5, we know that a redox reaction is an oxidation and a reduction reaction happening at the same time, and here we've got this. Okay, so with this topic you're going to be using page 12 in your data booklet quite a lot. Okay, so you're going to be using your electrochemical series and you should already be familiar with it from the National 5. Okay, so when we're looking further into this, okay, we have got Fe3 plus ions and Cu2 plus ions. Okay, we have said that this is a redox reaction. So from National 5, what you need to remember is the one further down will always happen. Okay, so when we've got Fe3 plus going to Fe solid, we're going to stick our finger on it. Here it's here. Okay, and the next one is Cu2 plus going to Cu solid, which is here. So basically what happens is the one further down always happens. Okay, so the one with the higher electron negativity value, which you can see at the side, is the one that always happens. Alright, so the way I remember it is the one further down is always happening, is always going to happen, sorry. Therefore, you are going to form your copper solid. Make this straight. Okay, so when you're forming your copper solid, we know that the one further down must be a reduction reaction. Therefore, so our copper is going to be formed, but now our iron's going to have to be flipped, because this is going to be the oxidation reaction. Okay, so what happens is your copper solid will be formed because your copper is further down. The further down reaction is a reaction that will stay the same, it will happen. The other reaction up above will be flipped, this will be your oxidation, and this is going to tell you if it's going to have an effect. So for in this example, we have started with the copper sulfate. Okay, so the Cu2 plus here would be bonded to the sulfate, the SO42 minus ion. Okay, if we were to add in some iron, like we've said, what's going to happen is this is going to go backwards and this is going to go forwards, and we're going to form our Cu, your Cu copper. In this case, your sulfate ions are spectator ions. Okay, they do not have an effect, they do not play a part in this reaction. Okay, so example 2 then, would a redox reaction happen if silver was added to this copper sulfate? So we're going to do the same again. You're going to find Cu2 plus going to copper solid, and you're going to find Ag plus going to Ag solid. Okay, you'll find these both on page 12. You're going to see what one's got a higher electron negativity, and you're going to see which one's further down. So the ones further down will have a higher electron negativity. Okay, so in this case we have got Ag here, and we've got Cu2 plus going to solid here. Okay, so remember the one further down will always happen. So Ag plus an electron going to Ag solid. Okay, this is the reaction that will happen, right? So in this case, your silver is further down than the copper, therefore it's not going to displace the copper. Okay, the copper will stay in solution and the Ag will stay as a solid. Okay, so by adding the solid silver, it's going to have no effect and a redox would not happen. So basically what you're looking for here is anything above this in the table would have an effect on the copper and therefore would displace the copper. Okay, but anything below the copper in the table would not have an effect. So for example, your silver is here, it's lower down. It's not going to have an effect on whether copper is displaced or not. Okay, so last example then. If chromium metal was added to a solution containing, SN2 plus, so tin2 plus, would a redox reaction occur? Okay, so again, we're just going to write them out what we've got. So we've got Cr3 plus going to Cr solid, and we've got Sn2 plus going to Sn solid. Okay, we're going to find these on the data booklet and page 12 even. Okay, so remember we're looking for tin solid, so we've got it here, and Cr3 plus here. So if we are going to add Cr metal into the tin solution, okay, what's going to happen then is your Cr metal is further up than the tin, therefore your Cr metal, so your chromium, is going to displace the ions of tin in that solution. Okay, so tin solid would be formed, so this reaction would happen because it's further down. Okay, and the chromium metal would displace it, it would take the place of the tin ions in the solution, and a redox reaction would occur. Okay, so a redox reaction is going to occur if a metal is going to be displaced, right? So for example, if you're adding in a metal that's higher up on the the electrochemical series, yeah? So if you're going to add in a metal that's higher up, you're going to have a displacement reaction. If you're going to have a metal that's lower down, you're not going to have an effect.